Thank you for joining this lesson. We are going to study a question in work, power, energy, and machines. And in this case, we are going to study a machine called inclined plane. Therefore, we are given a figure here whereby a spherical drum of mass 160 is being rolled up a plane inclined at 30 degrees to the horizontal. Therefore, the angle of inclination is 30 degrees to the horizontal. Then we are told that the force applied is 840 Newton. And the distance moved by the drum along the plane is 10.4 meters. Therefore, we have a drum here, which is spherical. Then we have a force applied here of 840 newtons. And we have 10.4 meters length of this inclined plane. Therefore, we are taught to determine the work done by the effort. We know that work is given by force times distance. Therefore, the effort itself is 840 newtons, and the effort is going to work through 10.4 meters so that it may raise the drum. Therefore, 10.4 times 840. This gives us 8736 newtons. 8736 newtons. Therefore, the work done is 87 Newton meter, because it is force times distance. Therefore, now that we have work done on the effort, we can proceed to Roman 2, whereby we are told that to determine the work done in raising the drum. Therefore, it is very important to note that the drum is being raised through a vertical height here, xy, which is not known. Therefore, we can first of all determine the vertical height. And considering this angle of 30 degrees and an hypotenuse of 10.4, then we can use the symbol trigonometry to determine this height, whereby we can apply the sine of an acute angle. So sine 30 is given by the opposite, which is not known, divided by the hypotenuse 10.4. To remain with the height, which is x, we will multiply 10.4 and the sine of 30, and the height will be 10.4 sine 30, 5.2 meters. Therefore, we have 5.2 meters here. So the vertical height is 5.2 meters. It is very important to notice that even though the effort is being applied through 10.4 meters, the load itself is being raised through 5.2 meters. Therefore, work done on the load, or work done in raising the drum, the work done will now be again force times distance, which will be a force of, the drum itself is 160 kilograms, which means 160 kilograms times 10 to make it newtons, multiplied by a height of 5.2. Therefore, when you multiply this with 1600, then we'll get 8320 Newton meter. It's very important also to notice that instead of Newton meter, we can also use what we call the joules to represent work. Therefore, with work done on the load and work done by the effort, then we can proceed to Roman 3, whereby we are told to determine the efficiency of the inclined plane. It is very important to notice that efficiency is given by the work output divided by work input multiplied by percent 100, or expressed as a percentage. Therefore, the work output is the work which is done on the load, while the work input is what the effort does. Therefore, here we will take 8320 and we divide it with 8736, then we express it as a percentage. Therefore, the efficiency of this inclined plane will be 736 95.24 95.24%. Therefore, the efficiency of the system is 95.24%. Finally, we are taught to give one reason why the efficiency of the inclined plane cannot be 100%. Okay, it cannot be 100% because the surface through where the drum is raised through cannot be smooth enough, and that means you have some friction. Therefore, because there is some friction to be overcome, then this system cannot be 100% efficient. So we can just give one reason as to that. The machine is never 100%. We can say this is because some of the work input is used to overcome friction. Some of the work input is used to overcome friction. So instead of the work applied on the effort going directly to lift the load, part of it overcomes friction, and that is why the efficiency of this system is not 100%. So thank you for following. Subscribe to Shifting Grades and share the link.